Hi, in this tutorial we have an exercise related to Lewis acid and Lewis base definitions. The exercise asks us designate the Lewis acid and Lewis base in each of the following reactions. Let's look at the reactions. We have three reactions and each reaction has two reactants and one product. So let's start from the first option. In the first option, we have here an alkyl halide and aluminum chloride, and this is the product. Basically, this is a Friedel-Crafts alkylation, part of the Friedel-Crafts alkylation reaction, but you don't need to know these details. So let's look at what is happening. Uh, the chlorine in this molecule in ethane, chloroethane, it's combining with aluminum chloride, and the chlorine and aluminum is bonding. And we know that we have three lone pairs in chlorine, and in the product, the chlorine is connecting with a sigma bond with aluminum. And since chlorine has lone pairs and aluminum doesn't have, so the bond will be initiated by the lone pair of chlorine. And if we draw the reaction mechanism, a curved arrow from one of the lone pairs of chlorine, it's moving onto the aluminum. So basically, that is just one arrow. It's not a complex reaction mechanism. So based on Lewis acid-base definition, definitely the chloroethane is electron pair donor. Let's write here electron pair donor, and aluminum chloride is electron pair acceptor. And based on these information, we are going to say that electron pair donors are bases. So this is a Lewis base, and aluminum chloride is a Lewis acid. And we know that metals generally accept electron pairs from oxygen, chlorine, and from the atoms that has lone pair electrons. So uh, most of the time, uh, metal salts are Lewis acid, and Lewis bases are generally species, organic species having lone pairs. Okay. After the first one, let's move to the second one. Second one is we have here a methyl alcohol methanol and boron trifluoride, and this is basically two reactants are combining into a single product. And when we look at the product, oxygen and boron is connected with a sigma bond, with a single bond. So if we write the lone pairs for species, for methyl alcohol, oxygen has two lone pairs. Boron, we know that it has incomplete octet. It has three fluorines attached. So uh, the sigma bond between oxygen and boron should be initiated from the lone pair, one of the lone pair electrons of oxygen. So this is the reaction mechanism. Basically, we are drawing a curved arrow. The curved arrow starts from the lone pair and it ends on the boron, and we are connecting oxygen and boron. So again, methyl alcohol methanol is electron pair donor, electron pair donor, and that's the reason why it is Lewis base. And boron trifluoride is electron pair acceptor, and for that reason it is Lewis acid. And we know that species having incomplete octet generally act as a Lewis acid because they would like to have octet as a result of polar reactions. And we know that methanol, methyl alcohol, oxygens, it has lone pairs and it is electron pair donor, and that's the reason why it's a Lewis base. And the last option, we have here a carbocation, tertiary butyl carbocation, and water. And what is happening? It's a combination reaction, addition reaction. Water will be added to the carbocation from oxygen. If you look at the product, there should be a bond formation between carbon and oxygen. And since carbon doesn't have any lone pair and oxygen has two lone pair electrons, so if you write the reaction mechanism with curved arrow, with one curved arrow, a curved arrow from oxygen lone pair towards the positively charged carbon, and we are making a sigma bond, single bond. So for that reason, water acts as an electron pair donor, and carbocation, this tertiary butyl carbocation, it is electron pair acceptor, and water is Lewis base, and carbocation is Lewis acid. Thank you so much for watching the video.